let x d1 and y d2 be the two matrix space. Let f and g tends to x and y be the continuous maps. Prove that the set curly bracket starts x belongs to x, f of x is equal to g of x is a closed set. Now proof putting a is equal to x such that x belongs to x and f of x does not equal to g of x. Consider an arbitrary a belongs to a, f of a does not equal to g of a, and d2 f of a and g of a is greater than 0. Putting n equal to d2 f of a g of a, as f and g are continuous, so for given epsilon greater than 0 there is a real number delta greater than 0 such that d1 x a is less than delta and d2 f of x f of a is less than epsilon, and d2 is equal to g of x and g of a is less than epsilon. Now n is equal to d2 f of a g of a, which is less than equal to d2 f of x f of a f of x plus d2 f of x g of x plus d2 g of x g of a, which is less than d2 f of x g of x plus 2 epsilon when d of x a is less than delta. We take n is equal to 3 epsilon for particularly, so which implies 3 epsilon is less than d2 f of x gx plus 2 epsilon when d1 x a is less than delta, so which implies d2 f of x g of x is less than epsilon and d1 x a is less than delta. It shows that a and delta is subset of a, which implies a is the interior point of a, so which implies a is open, so a complement is closed. So putting a complement is equal to x such that x belongs to x f of x g of x, so it completes the proof.